All right, so we're going to continue our little lab practical review with a look at rocks, and we're going to kind of look at one of each kind of rock that you might be able to see on the lab practical or have seen already in your studying. First of all, though, let me go back over to our charts and show you those. These are right, again, out of your lab manual. And I was able to save these as little pictures. So you have an identification chart for rocks, for igneous rocks, excuse me, metamorphic rocks, and we have sedimentary rocks. So what I'm going to talk to you about now is how to take a sample that you have no idea anything about and kind of go through and figure out what it is. So I want to start by saying it does no good to have these three charts if you don't know which one to be on. So if you can't figure out whether it's igneous, sedimentary, or metamorphic, then you're in trouble already. So let's talk about how you might do that. We're going to take a look at the sample first, and I want you to just kind of look at what it looks like, what's obvious about it, and what's not so obvious about it in a lot of cases. So I'm seeing probably one of the most dull, boring looking pieces of rock ever. It looks like it's crumbly and it breaks pretty easily. It looks like it has kind of like these, it's kind of like a layered appearance. They're kind of thick layers of something. One thing that isn't here on this is I don't see any crystals. I don't see evidence of really, really like thin crystal layers within the rock. I don't see alternating color patterns. I don't see really any color at all other than one, which is gray. Okay, so chances are if you're looking at a sample and it is boring looking and very bland and very uniform in color, then you're probably looking at a sedimentary rock, just saying. But let's go over to one of the charts that I've given you. It's an attachment within this lab practical folder. This is something I put together, and it's not a perfect guaranteed method of anything, but it certainly is helpful. You need to decide whether or not this is igneous, sedimentary, metamorphic. And the way to do that is to kind of take those observations that we just made seconds ago and use them and see if it fits anywhere within this. So what I saw was a boring rock, very bland looking, not very crystalline. So if there are no crystals visible, most of the time you're going to be able to eliminate igneous and metamorphic, because igneous rocks show a very large or small multicolor crystals in it, and you probably can almost guarantee that it's igneous in those cases. If it's not one of those two situations, it could have gas pockets or a very, very glassy look to it, which they're so obvious when you see them that you would also say, wow, that's igneous. So those interlocking crystals of multiple colors are definitely a giveaway for igneous rocks, as are gas pockets and glassy texture. Metamorphic is similar. You've got crystals, so you're going to see sparkles in the rock. You may see, well, you don't always see sparkles, which you could, but you may see evidence of foliation, which is those crystals are arranged in different layers, and sometimes they're so arranged that you can see color layers, like maybe it alternates like a zebra, like black and white, or pink and gray, something like that. You'll see different layers. That would be banding or extreme foliation. At the very least, you might see really, really thin crystal layers, like they're almost like pieces of paper that are set on each other, that they're that thin. That's evidence of foliation. Also, foliation, you might see a shine to it, similar to like if a mineral had good cleavage pattern where it shines very well from the whole surface. That would also be evidence of foliation in a metamorphic rock. The ones that do have very obvious crystals are the non-foliated kind. You'll see lots of sparkles in these, but they're not necessarily multiple colors. So you're more going to see a blend of colors or a swirl of very, very similar colors. They're all very similar colors. So we're talking like red and pink, or white and gray, and you'll see like that swirling kind of blend of those two colors or whatever. So you're not going to see like in an igneous rock, you might see pink and black and gray and white, or even red in some cases when it's garnet. So you'll see lots of multiple colors in igneous, whereas if it's crystalline, but it's very kind of more uniform in color or swirled in color, it'll be a metamorphic variety. So that brings us to looking at sedimentary. So for this sample, once again, let's just take a look at it and see if it fits the bill here. Again, very plain color. Looks like just some layers of mud, essentially, that hardened, and it's kind of on top of each other, layered up like that. They're not paper thin layers, though. These are kind of thick, chunky layers, and it looks like it's very fragile. So going back over here, I'm looking at, it could be a crystalline sedimentary rock or a clastic sedimentary rock, because I don't see fossils in this particular one, although you could get fossils in it. If you see a fossil, by the way, guaranteed 100% of the time to be a sedimentary rock. Okay, so either way, I'm in the sedimentary world right now. I don't necessarily see bits and pieces, but we're going to talk about what that really means as we finish up identifying this rock. I don't see any sparkles in it, so I'm leaning clastic. I do see the uniform color or texture, so we'll just have to use our ID charts and figure it, or our chart and figure it out. But at least by kind of using your observations and this giveaways slide thing here, you can hopefully hone in on which of the main three categories of rock it is. So it is definitely not igneous, so we're going to switch and look at the other ones here. Let me see if I can get that. Just make that go away. Sorry, we're experiencing technical meltdown there. There we go. Let's get those up. Okay, so we are on the sedimentary chart now, and here's your different options. Okay, you have either they're calling it detrital sedimentary rocks or chemical / organic. Detrital is another word for kind of classic textured rocks, where it's made up of little bits and pieces of things. The other ones, like I said, if it's a crystalline or chemically formed sedimentary rock, they're going to have a very uniform color texture, and they will have very much limitation in the way of, like, you won't see different pieces, you won't see many, if any, crystals at all. So let's just kind of read through some of this description and see if we can narrow it down, or at least eliminate some stuff. If it's let's try to eliminate these crystalline ones. No visible, I mean, a lot of these it might fit, but I did give you a hint, by the way. It had a greasy feel to it. That actually was a hint on that photo. So that means if there's a greasy feel to something, that it actually is made up of sediment, or some sort of really small sediment size. Okay, the reason it feels greasy is because there are bits and pieces that are actually in this rock that are literally so small they're getting into the oils of your skin, and you feel what it gives you, kind of a greasy feel sensation to the rock when you're holding it. So it's very smooth and silky soft, basically, is what that means. So back over to this, I'm just going to say, because of its appearance and it looks crumbly, that it's going to not be in our chemically formed. These ones are going to look very similar in color, but they're going to be very smooth, they're going to appear like they're tougher and harder and more sturdy, whereas that one appeared crumbly. So that's a great way to eliminate some of these. Okay. Also, down at the bottom, you see coal. That's one of the few black rocks that are out there, especially in the sedimentary world, where that would be the only one that's actually jet black. So you can eliminate that one too. So I'm going to say, let's stick with our classic varieties of rock and just kind of narrow it down. And did you see pieces of gravel in there? Is a great question. Or sand. Could you see sand, silt, or gravel as part of that rock? And the answer is probably not. You couldn't see any sediments. But if it feels greasy and it does it does look crumbly. It's going to be one of these. And the greasy feel comes from the fact that it is the smallest size sediment, and that's why it gets into the oils of your skin and gives you that greasy sensation. So color wise and texture wise, you can actually see what they're trying to show you here with these little pictures. This is like to actual size, and some of the bigger ones can have even bigger ones than this, but you can see how big sand grains are. That rock did not appear to have sand grains. It actually appeared to be completely a flat gray. So that puts us down to either shale or clay stone, which are almost the same thing. But for siltstone, in that case, you're actually, the sediments are just big enough where you can actually scrape them off and it'll feel like a fine dust, not greasy, but it'll feel like almost dusty. So that's what siltstone would look and feel like. So it is not siltstone here. But I would be tempted to put either shale or clay stone. And if you look at if that were the question, it would probably have shale as the answer choice, and you'd pick shale. Claystone shale, the only difference is this is actually more of a claystone than a shale. It's just looser, more crumbly, and weaker, or more weakly held together. And it's more likely just pure clay rather than clay mixed with a few like mud and clay mixed together. Okay, so that's what that one is. I mean, I picked that one because it's kind of it's a tough one. It's boring and it's very bland looking. But if you hone in on how crumbly that thing looks, then you can really narrow it down. And let's look at some of the other possible questions you might get. This is the most common question on the test, other than what is this rock called? This is, what is the origin of the rock? Well, that's the first thing we did, is we went around and tried to figure out whether it was sedimentary, igneous, or metamorphic. There are only 3 rock types. So don't, when you see something like lunar, please don't pick that one. That's just there to distract you. Okay, so what did this rock used to be? Well, if it were sandstone, we would say it used to be sand grains, and then they get glued together by mineral cement. Lava would form a different type of rock, which we call igneous. So that would not be the answer, simply because we're not even remotely in the igneous world right now. Clay or mud, that's the answer. So this would be answer C here, because it used to be clay or mud. But dead plants, if we were looking at a piece of coal, you might pick that as your actual answer. If this were coal, you would pick dead plants. But since it's clay or mud, that's what we're dealing with there. So moving to the next category here, or next picture. I've got a couple of samples. Now, what I want you to notice right off the bat, this is, first of all, there's a lot of flatness going on. And as soon as you start to see flatness, that makes my mind think one thing, and we'll talk about that in just a second. The other thing is I see almost like paper thin layering going on. That is another major giveaway of something. So we're going to go back over and we're going to try to figure it out. What we don't see here, this does look similar to the previous picture in a little bit of, in a few ways, but I'd say the layering on these ones are much thinner, and they look, even though they're a little bit jagged, they look a little more solidly held together. So that's an important fact there. So one thing I do not see anywhere are crystals. So that's another thing to think about. So let's pop over to this guy and let's see if we can figure it out. I don't see bits and pieces here, no fossils. I mean, I'm distracted by this crystalline uniform color texture thing, but again, the layering takes precedence over that paper thin layering. So we'll talk about that. I don't see large or small interlocking crystals, gas pockets, or it's not glassy and shiny and sort of reflective of light. So we're not going to look at that. So that really brings us down to either, if you were still hung up on this, it could be a crystal and sedimentary rock, or when you see these minerals align in crystal layers, that's what I'm talking about. That's the paper thin layering that we saw. Now, if that gets more, like metamorphism has different grades, if you metamorphose rocks more, those can become much more obvious layers that are a little thicker, but you'll start to see the different colors showing up. But there'll be, that would be an extreme foliation pattern. This one's not quite there, but it certainly does show those paper thin layers. Now it isn't non-foliated because I don't see any crystals, but this really tells me I'm looking at a metamorphic rock. So what we want to do is hop over to those charts again, and we're going to not look at the igneous, we're going to pull up the metamorphic one. So real fast, I mean, you have 4 options when it's a foliated rock. So knowing that that layering is going on is super, super important, super helpful. Now going down to the non-foliated ones, that's where you start to see some of the crystals, and there's some other issues down here like metaconglomerate. These are specific situations where if you had what used to be a conglomerate actually get heated and pressured so that it distorts the little pebbles that are in it, you would see that very clearly. Marble and quartzite both have that kind of blended crystals pattern that I was talking about. Anthracite coal would be jet black and shiny. So you'll see that possibly also, and there's some pictures of that in our slideshow that I'm sharing with you also. Hornfels, serpentinite, there you're going to see that just boring gray color. And I'm actually going to tell you, since there are a lot of different looks to these, I'm not going to ask you about these two actually on the lab test. So just keep that in mind. So you can cross them off right away. But certainly anything else that you see on this list is fair game. But for that particular one, we are in the foliated area, and you got to kind of read through the distinctive properties and see what you might agree with. First of all, if you don't see grains or any kind of alternating colors, you're not going to be in the medium or coarse texture area. So those are just not going to be the answer. And what you do see, let's look at these two. Excellent rock cleavage means that that's what you've got, those sheety, micro thin layers of crystal that you could actually, if you put a screwdriver in there and tapped it with a hammer, you can get it to split. That's what they mean by excellent rock cleavage. Smooth, dull surfaces. That definitely looks like it had a smooth, dull surface. I do agree with the fine grain size there. This next one breaks along wavy surfaces with a glossy sheen. I mean, yeah, it would break, ours would, but they would not be as wavy, and you would also not see that sheen to it. So it's a close call, but I think we've got slate, and that will be the answer that I pick for that one. So that's what slate looks like. And the fun part about slate, in the old days, it used to be used as tiles, either on roofs or on floors. This can come in a lot of different colors. This one's the black gray version, but you can see slate, it always looks the same in terms of these paper thin layers, but it could come in green or red or purple or blue, all different varieties. But the foliation is so obvious and evident in that rock. All right, our last one here. There's nothing really associated with this. It's just, let's figure it out. This, I hope you would agree, you're looking at crystals. Lots of them, and they're actually kind of big and very obvious in size. So I've got some white ones, some black ones, some grayish ones, and it looks like I've even got some really wild looking blue ones in here, which would be probably an azurite mineral. But really overall, I want you to ask yourself, does this rock look predominantly like it's a light color or a dark color? And hopefully you can see that this is maybe like a 60-40% in terms of dark color over light color. So it's a little more dark than it is light. So that's an important thing when you're going to identify later. And I also need to say, okay, well, which of the 3 rock types is this? I'm seeing crystals, number 1. Are they arranged in any pattern? And are they different colors or not? Let's see. Well, I think I'm looking at multicolor crystals. I'm definitely not seeing any patterns, which usually means it's a metamorphic, or swirl, that could mean metamorphic as well. I think that we're looking at a really classic igneous rock, and I'm actually looking at fairly large interlocking crystals. So that's why I would pick igneous for this one. And that's why we're going to go to the igneous rock chart and see where we can find out what it is. So let's see what we've got here. Let's slide that out of the way. We're now over to the igneous rock world. And basically what you want to start with is the texture. So does it look like it's coarse grained, fine grained, porphyritic, glassy, vesicular, pyroclastic. Now, we already probably know the answer. Definitely not glassy, definitely not fine grained. Porphyritic means that you have fine, fairly fine grain with giant crystals embedded in it, like literally like exactly like that picture. It's not glassy, we said that. No, vesicular, I don't see gas pockets or holes in it of any kind. And for our, this stuff right here, that picture really says it all. You've got basically debris trapped in what looks like solidified ash, and it would be very obvious if I had a picture of this that was bigger, you would definitely see it look just like that. That is not what we're looking at. We're looking at crystals and lots of them. So I'm going to go with coarse grained, and you have 4 options once you make that call. You have granite, diorite, gabbro, and peridotite. So you have to now remember what color we said that rock was, because if you look at the bottom of the chart down below, I'm trying to move it because I have my Zoom screen in the way. The darker ones are to the right, and we said maybe 60% dark, so that falls in this 45 to 85 range. Now, if it's really, really dark, it actually, not just dark, it actually starts to turn more of a green color because you get these really rare minerals in it that make it, because where it was formed, make it have a green appearance or a greenish appearance. This one wasn't quite there. So I also like the fact that it had so much lighter colored grays and whites in there. I really like where we said it was about 60%. So if you kind of do the cross where you go over and down, we are actually looking at a sample of gabbro, and that is the rock that we will go with as an answer on that. So hopefully that kind of helps. I really hope that this chart in particular can get you going in the right direction, because rocks can be pretty mysterious when, you know, it's just looking at an unknown sample in front of you. But I think if you can get which of the 3 big types it is, it should really get you off in the right direction, so you can use the other charts that you are provided to narrow it down. All right, so that's what your lab practical will look like. You're going to get lots of questions like that. And so hopefully that helps you get prepared better. So study up and good luck.